Hey everybody, we have two expressions and three unknowns, but it turns out there's enough structure to actually find a solution. Since this is an arithmetic sequence, the common differences have to be equal. So x minus 11 has to equal to y minus x has to equal to 436 minus y. And again, what characterizes an arithmetic sequence is the presence of a common difference. Okay, and so these are the three differences, right? X minus 11, y minus x, and 436 minus y. They have to be equal. That's just the definition of an arithmetic sequence. So we never had to explicitly write down something like D for the common difference. We just know these three differences have to be equal to each other. Okay. Now, in a similar fashion, we have a common ratio for a geometric series. And so the common ratio here, and I put a 1 here intentionally just to make it the math easier, a little bit easier at least. A over 1 is the ratio between the second and the first terms. And then we also have y minus x over a. So in the same sense that these guys up here have to be equal with respect to addition, subtraction, these have to be equal with respect to multiplication. Okay, so this is the structure that makes this work out nicely. So we're supposed to find all values of a. When I first composed the problem, I thought there was just one. Now I won't go through too much of the arithmetic right here, but I did use these three statements. Okay, and maybe my way is not the most efficient. Okay, but anyway, we can establish that x is equal to 458 over 3. Again, I won't go through all the details there. Hopefully I left enough information here where it makes it clear. So we get x is equal to 458 over 3. Notice it will, once we find y and x, we'll be done because a squared will just be equal to that difference. Okay. So we have found x right here, and also we found y by just using everything that we've composed right here. Y is equal to 2x minus 11, right? Y is equal to 2x minus 11. And so that's why, again, you can check it out yourself. So this is our expression for y right here. This is our numerical value for y, okay? And so that we didn't really have to write down what the geometric series was, or the arithmetic series was, but I just did it for a little bit of clarity. So we know that this would be x and this would be y. And again, you could get by without actually writing down this arithmetic sequence, okay? The key is to know what y minus x is, okay? And y minus x with these two choices is 425 over 3, okay? Now, so again, this is something we've already written down, but we know what y minus x is right now. So again, when you cross multiply these fractions, you end up with a squared is equal to y minus x. Okay, but we know that y minus x is 425 over 3. And this certainly implies that a is equal to plus or minus the square root of 425 over 3. And that's a suitable answer for a competition problem. They don't care. Middle school and high school, sometimes they expect you to rationalize the denominator, but it's fine to leave the answer this way. This is the answer, independent of whether or not you do that annoying rationalize the denominator thing. Now, so that's the answer. Now, let's see. What can I do here? Again, we could simplify this because 25 it goes into this, what, 17 times? So you could actually write this as plus or minus 5 times the square root of 17 over 3, I suppose, if you want to do that. And then you can in turn, rationalize this. I think I did the arithmetic correctly right there. 16 times 25 is 400. 17 times, okay, so then this looks right. The 17 looks right. 17 times 25 is 425. All right, so I took the square root of 25 and brought it out here. And you could rationalize, okay, I've gone this far. Let's see, what would this be, plus or minus? Plus or minus 5. I think it's gonna be, I think I got it right here. Plus or minus 5 over 9. Is that right? 5 over 9 times the square root of 51. So this would be the high school, middle school answer. I think I did that right. Let's see, 3. Yeah, I guess so. Okay. So again, I multiplied top and bottom by 3, right? And that gave me the 51 here. But I would have the square. This is supposed to be 3, right? Okay, but in any event, this answer right here is suitable for contest problems. I think. I don't think at the high level they don't want to waste time just doing something like this. Even though I may have proven I can't do this. Let's see. I think maybe this is supposed to be 5/3, probably 5/3, right? Because yeah, I'm not sure. Anyway, thanks for viewing.